Did you know Python comes with over 60 built-in functions that you can use without importing a single module? Today I'll explore 12 of the most interesting and useful built-in functions with examples, gotchas and a few nerdy details you may not be aware of. Why 12? I have no idea. It just kind of happened. Let's dive in. The first function I want to talk about is the help function. This is mostly used for the interactive interpreter. And the way that this help function works is that, let's say, from data classes, we're going to import data class. So once you've done that import, you can simply type help data class, then you're going to get some information about that particular decorator. Or you can also directly launch into the help environment, and then you can simply type the module that you want to know more about. Let's say URLlib, for example, and then it's going to give me the help for the URLlib. Now, of course, there's always Google and the internet, but if you don't have internet or you just very quickly want to look up some documentation, the help function is pretty neat. And you can just keep a terminal like this open, and in your editor, you can just switch to this whenever you need some more information about a particular module or function. Part of this, by the way, is also integrated in your IDE. So I'm not that much of an interactive interpreter guy myself, so I don't use it all that often, but it's good to know that it's there. The next built-in function that's really neat is dir. And I have a Jupyter notebook here to show you how this works exactly. So for example, let's say define a couple of variables a and b. So if you print dir, in this case, what you're going to see is that there is the entire scope. So we have the built-in Donder dictionary. There's a couple of other global scope things like the name and the package. But as you can see at the end, we also have a and b in there. So dir simply lists the names in the current scope. Now there are some things to be aware of with dir. Let's say here I have an example where we have a dir with a custom invoice class that sets a client and a total. And there's also a string Donder method implementation. So when I run dir on this, but then when I scroll to the right, you actually see that the instance variables that we created in the initializer are not there. So dir doesn't automatically show you this. And that is because I'm calling dir on a class. And the instance variables are set in the initializer, so it's not part of that. However, if you do dir on instance of class, so here I have that same invoice with the client and the total, then you will see we will get these things. So I just have to scroll right to get to them, but they are going to be right here, client and total. So depending on what kind of thing you're inspecting, you may or may not see the data that you expect. What you can also do in a class is override the dir Donder method like I'm doing here. And then you can actually specify what a call of dir on that particular class should show. So in this case, when I run this, then you see that this is now what we get. So you can involve all sorts of interesting Python magic here to make dir say whatever you want, basically. So be careful with this. You can also call dir with a module. In this case, I'm importing math, and then I print the directory of that particular module. And then you can see with all the math functions available right here. You can also call it on a list. Then this is what you're going to get. So you get all the list Donder methods, and as well as a couple of other methods that list has, like append, clear, etc. You can even call dir on a function, and then you're going to get a bunch of Donder methods that are defined on the function. Remember, in Python, everything is an object, including a function. Or you can call dir on the non-type. Again, that's another object in Python. In short, this shows that dir basically allows you to expect anything in Python. The next function is range, and this is also really helpful. In fact, range is not really a function, it's more of an immutable sequence type. The advantage of the range type, rather than just putting all those values in a list or something, is that the range object is going to take the same amount of memory regardless of how wide the range is. So that is actually really neat. Here you see a very simple example of using range. So I'm using that in combination with a for loop. And when you do that, you see that it prints from 0 until and including 9. So it's exclusive of 10. In other words, exclusive of the upper bound. And you can also see that in this example, where if I go from -10 until 10, and that's inclusive of that lower bound. So in fact, here there is a default value of 0 for the starting value of range. And it ends at 9, just like the one before. Now you can also do a lower bound of -10, upper bound of 10, and a step of 2. So what that's going to do is going to skip the odd values in this case. So it will still start at -10, but then of course the upper bound is going to be 8, because 8 plus 2 will be 10, and 10 is excluded of the actual range. You can also print the type of the range, and as you can see, that's a class range. And range itself is a subclass of sequence. Now, because range is a subclass of sequence, it means you can access all sorts of methods in it. For example, you can use the square bracket notation. You can also fetch the last element, or you can get the length of the range, or the index of a certain value, or a count, or you can create slices, reverse it, compute the minimum and the maximum of the range. And all of that works just like you would expect with a sequence. So this is a really neat feature that few people actually know about. You can also do reverse range. So if you start with 10 and you go to 0 and then you do step -2, then this is what you get. And if you have a range from 10 to 20 with a negative step, then you're going to get the empty list, because by applying the step, you will never get to the value of 20. Before I continue, if you're serious about mastering Python and software design, I've created a free guide that walks you through the 7 steps I use to design software. Get it at ArjanCodes/design guide. It's packed with practical tips and examples. Check it out, the link is in the description. The next one that I want to talk about is all. What all does is that it's going to take some iterable and then it's going to return true if all the values in that iterable are truthy. Examples of truthy values are a non-empty list, or a positive integer, or a non-empty string. Falsy examples are none or 0. Here I have an empty list, and if I call all on the empty list, it's going to be true, because all the elements, even though it's 0 elements, they are truthy. If you have a mixed list like this, containing some integer values, then it's going to return false, because 0 is falsy. If I change this to a positive number, then you're going to see it gives me the result true. And same if you have a non-value, because none is also falsy. So there you go. Here's another example where I have a class is even, and that simply has a value, and I use the bool dollar method to determine whether the value is even. And in this case, if I have 1, 2, and 0, then this is going to return false, because this first element is odd. Actually, the comment here is wrong. If you change this to, let's say, 8, so then we all have even numbers, then this is going to be true. But of course, in Python, you can combine various types of elements. So I could also change this to none, which again is falsy, and then all is going to return false as expected. And this works because all actually uses this dollar method. Now, if that dollar method isn't defined, then it's going to look at the length. So in this case, let's say I have a shopping cart that has items, and this gives me the length of the items in the cart. And then here, as you can see, I have 3 carts. And the first 2, they have items in them, but the last one doesn't. And that means that all is going to give me false, because it checks the length dollar method. If you have both length and boolean, like what I have here, then actually bool seems to have a higher priority than length. Because in this case, I have a cart with a single item B in there. And actually, if you look at what these functions return, bool returns true in this case, because A is not in the items. And length returns false, because this is going to give you the empty list. But if I change this to contain the item A, then in this case, bool is going to return false and length is going to return true. So when I run this, then we get false. So bool has higher priority than length. Kind of a nerdy detail, but still interesting. All also works with strings. So if it's non-empty, then it's going to be true. And an empty string is also true, because there are no elements, similar to all on an empty list. And finally, all works with iterables, and that also goes for generators. So in this case, for example, I can use the range function that I talked about before, and then check this generator of booleans here, and which is going to give us true, because all of these conditions here are true, since the range is positive. And here it's going to give us false, because of course the range starts at -5, so not all the elements are going to be positive. Now, related to all is the any function, which checks that at least one element in the iterable is truthy. You can see a few examples of that here. So again, the empty list, it doesn't have any truthy elements, so this is going to give us false. Here I have a bunch of mixed values. Since 5 is truthy, that means that any is going to also give us true. One thing you do need to be careful of with generators is that any is going to stop after it's going to find the first truthy value. So if you basically generate infinite number of falsy values, then basically it's going to run forever. And that's what you see here. So I have some infinite sequence which just returns positive numbers. And I'm going to continue until I find the first negative number, which of course will never happen. So this is just going to continue on and on and on. So I'm going to interrupt that. And here you see an example where it doesn't continue forever, because in this case, I will stop as soon as x reaches the value of 10. The next function is zip, and this is also really helpful. It allows you to take multiple iterables and basically turn them into an iterable tuple of the values. So in this case, for example, if I have names and scores, I can create a zip. And as you can see, we get, in this case, a dictionary that maps this value to this value. If I turn this in a list, then you can see that zip actually creates these tuples. So this is really helpful if you need to iterate over multiple lists or sets at the same time. And note that it's going to take the shortest of the two. So if I add another value here, for example, like so, and not add a score, then I will print this. Then you can see that this value is simply ignored until, of course, I add a score here for John, and then it's going to be added. So zip takes the shortest iterable. Now zip is lazy. It's only going to generate those tuples after you actually call it. So if I do this, for example, and then I change the values here, so what will happen is that this will only be called when I call the list initializer on it, because then it's going to extract the value. So what I did here is actually going to end up in the list. So be careful with that. Here's an example of how you could use zip. So in this case, I have these two lists and I want to iterate over them at the same time. And then this is how you can do that. Next up is filter. And this is really nice if you don't want to use a for loop like some kind of Neanderthal, but you actually want to use fancy functional programming. You can use the filter function to filter elements from a sequence depending on some condition defined in a function. Here you can see an example of that. So I have a list of numbers and then I call filter on that list of numbers and I give a very simple function here, lambda function, that determines whether the number is even. So filter is going to check each of the elements in the iterable, and then it's going to only keep the ones that actually adhere to the conditions. So when I run this, we get only the even elements in the list. Now you can use this with lambda function like this, but you can also use a function that you define somewhere else in the scope. So for example, here I have an isPositive function, and then I'm using that function to filter out the only positive numbers in this particular list, which is 1 and 2. If you supply none to the filter, so there's no function at all, it's only going to keep the truthy values. So this is what that looks like. This is really great for quick data cleanup, or when you just want to remove any null data from your list. If you're dealing with objects, like in this case I have a user which has a name and an isActive Boolean value, then you can also use filter by directly accessing the elements in the instance. For example, here I'm only keeping the users that are actually active. When I run this, we get Alice and Charlie because Bob is no longer active. The next function is map, and this is also really helpful. I use map quite a lot. What map allows you to do is apply a function on an iterable and then compute those values. So let's say I have a bunch of Celsius values here. Now what I can do is use map to call this particular function here that converts Celsius to Fahrenheit and then print the list of Fahrenheit values like so. And you can also use this with built-in functions. So for example, here I have strings, and then I can create the uppercase string by calling string.upper on these particular strings. And then this is what we're going to get. Or here's another example where, let's say you want to map integer conversion to a list of string values. Now, if you just define the result like so, then nothing happens. But as soon as you do something with the results, then the computation is done and this is printed. So for example, here you can see that the type of result is a class map. But then when we turn it into a list, it's actually being computed, and then we get the list of integers 1, 2, and 3. Now I have a few more built-in functions I want to go over. If you're enjoying this video so far, give it a like. That helps me a lot with reaching more people here on YouTube. I really appreciate it. Next up is iter, and this allows you to create an iterable from, for example, a list, a set, or a dictionary. And then what you can do is call next on that to get access to the values one by one, iterate over it. Then what happens, as you call next, when no more elements are left, it's going to raise a stop iteration. So when I run this, then this is what you get, 1, 2, 3, and then end of the iterator. It also works on strings, obviously, so then you're going to get this. Another cool thing that you can do with iterators is repeatedly call a function, like what I'm doing here, until a certain sentinel value is reached. In this case, that's stop. So if I run this, then I can now enter something, hi, and that basically gives me this, right? I can just enter a bunch of things, and when I enter stop, then now it's going to stop. So this is a really neat feature that I use from time to time. You can also create a custom iterator by implementing the iter dollar method and the next dollar method. So in this case, I have a counter, which has a current start value and an end value. And then basically it will increase the counter until it reaches the end. So here I create a counter from 1 till 5. And then I simply use a for loop to go over the values. And I can do that because these dollar methods were implemented. And then you get this as a result. Iterators also work with a generator. So here I have a generator function that yields values of I from a range of 0 till 3. And then I can simply use that iterator directly and call next on it. You can also use this to read lines from a file, like what I'm doing here. And then actually this file contains a single line. So then it's simply going to print those lines. Next up is slice, and that's also really helpful. So slice allows you to create a subset of an existing iterable and create a new iterable out of that. So let's say we create a slice object from 1, 5, and 2. And you can define a slice by creating a slice object. So in this case, you supply a start value, start index, stop index, and a step. So in this case, we want to start at index 1, we stop at index 5, and we take step 2. So we're going to get 1 and 3. So when you run this, then this is exactly what you get. And here you can see how that works. So you have a numbers, a list of integers, and then you can pass this slice between the square brackets. So this is the slightly longer syntax, but you can also use a slice directly by using the column notation. So let's say I want to have from 1 till 5 with a step of 2, and then this is going to give us exactly the same result. If I change the step size to 1, then you see we're going to get this as a result. So depending on what you need, you may want to define it like this, or you may want to define it directly as part of your square brackets. So this is actually pretty interesting. A few people know that you can use slices in this way, and then this allows you to actually create them dynamically, which is kind of cool. You can also use slices with strings. So in this case, I'm taking the slice from 7 until 13. That's going to give me Python, but of course you can also type it like so. And then you're going to get exactly the same result. You can even use slice with multidimensional arrays, which is also kind of interesting. So here I have a matrix, which is a 2-dimensional NumPy array. And then you can use slices to get a row and a column slice. And then this is what you're going to get. And just like before, you can define these ranges in exactly the same way, either by using slice objects or by simply directly defining them in the matrix. And this is going to give you exactly the same result. I use slice quite a bit. I think it's a really helpful tool to quickly get access to a subset of a particular group of data. So the next function that I find very helpful is type. And this is going to give you the type of a particular value in Python. So here's a few examples. So we have 42, which is an int. 3.14 is of class float. We have a string, we have a list, we have a dictionary. It also works for classes. So basically, if you run type on an instance of a class, then you're going to see that it's a class in the main scope called myClass. You can even use type to dynamically create a class. So here I have dynamic class, which is a type dynamic class. And then I'm going to provide it with attributes and even methods. So then if I run this, then this is what we get. And we can call the method that's going to output hello. I don't recommend that you actually do this, but it's really interesting that this is actually possible in Python. Here's another example that's also interesting. So I have a parent class and I have a child class. That's a subclass of parent. Then I create an instance of child, and I'm going to check whether the type of this object is a parent. And that's actually false because it's actually a child. So it doesn't check for subclasses. If you call is instance, then this is going to return true because child is actually a subclass of parent. That's the difference that you see right here. So don't use type to check inheritance relationships, use isInstance for that. That being said, I don't use these very often in my code because often it means that there is some design issue. There's a few rare cases where it is helpful to use isInstance or type, but typically I only use these for debugging purposes. The final function that I want to show you is vars, and this returns the dict_dunder object as a dictionary. So if I have X and Y here in my local scope and I print vars, and what you see here is that I get the values in this local scope. And this provides me with a bunch of data. Now, I normally don't use vars directly like this. It's not that useful in my opinion. But if you have a class, let's say a point, in this case, and I have an X and a Y value, and I create an instance of that, and I print the vars of point, then I'm going to get the instance attributes. And this is actually quite helpful. It's also interesting to see what happens if you dynamically add attributes to a class. So here I have my class, which has a single attribute, X, that has value 42. I create an instance of that class and then it prints the vars of that instance. So that's going to print this. That's what you see right here. Then if I add a new attribute, like what I do here, then I can also print the variables of the instance and it's going to update that. So that's what you see right here. And then finally, of course, I can also access that by simply accessing the Y value on object. Now, I would not recommend dynamically setting attributes on an instance like this. I feel like it leads to pretty brittle code if you're not careful. So I would typically avoid that, but at least know that vars always gets the latest list of instance variables. One way that I've used vars in the past is if I have some object and I need to store it in a JSON file, for example, then I can use vars to simply get all the attributes and the values. And then I have a dictionary that I can store in the JSON file. Now I'd like to hear from you. Which of these functions do you use the most? Did you know about all these functions or did you discover a new one today? Let me know in the comments below. Now, mastering these built-in functions means less boilerplate and more expressive Python code. But that's just one aspect of being a great Python developer. In this video, I go over the most important features of Python that you need to know, including one which I see many developers struggle with. Thanks for watching and see you next time.